Hey, good morning, everybody. Let's get on this new CPM assignment. We're doing 1.2.4. It's pretty close to being the end of Chapter 1 here. Okay, so again, we always do the review and previews. I see 1.2.3 there. I'm going to keep flipping. And I see 1.2.4 on page 39, if you actually have a textbook, but remember there's no page numbers on the ebook. So if you're up there in the ebook, that ain't going to help you knowing that. Page 39, right? But we don't, that's where it starts. We always do the review and preview, which looks like it's starting over here on page 44. Okay? Quite a few problems on that, right? 1-85 all the way to 1-92. So that's what we want to include as part of our heading, remember? I want to include the problem numbers. So go ahead and put the heading in there. I'll call this guy Joe Student. And we're talking about October 4th, 5th. Depends on who you have, huh? Right? We're doing CPM Lesson 1.2.4, and the problem numbers we're doing is 1-85. I'm going to write the word through. Now remember, this through is O-U-G-H, right? Not E-W. I didn't throw something. This is from this problem all the way through 1-92. Okay, and what we're doing first, 1-85, it says you're using your multiplication table to figure out the missing number in each line. So 15 times what is 225? Well, I don't know about you, my multiplication table does not go that far. 15n equals 225. But remember, if I had a basic fact like 6 times 3 is 18, there's what they call a fact family, remember? But wait, there's more. And I can do 3 times 6 is 18, but I can also do division and do 18 divided by 3 equals 6, and 18 divided by 6 equals 3. Notice the different ways you can write divide there. So 225 divided by 15 equals what? Well, I'm going to let you figure that out. Okay, I think you can do that. That was A. B is not written so much as an algebraic equation that you have to solve. It's written kind of like a math problem. 84 divided by 12. How many times does 12 go into 84? And they're saying that equals n. So what does n equal on this one? And again, when you get done there, you're going to say n equals. And you put a box around your problems and a small box around your answer. Okay, we're going to do the same thing here. After you figure out how many times 12 goes into 84, leave myself a little bit more room on the next one. 11 times n is 143. So that means 143 divided by n should equal 11, and 143 divided by 11 should equal 10. So let's see how many times 11 goes into 143. And again, put a box around your problem and a small box around your answer. D, 182 divided by n equals 13. Well, remember what that means. The first number goes inside the box. But this also means that 183 divided by 13 equals n. So let's try this to figure out what the answer is. Okay, I think that's enough of a hint for you guys to go do this. 186, Jack has 4 tiles and wants to find out how many different shapes he can make with them. Sketch all the arrangements. Okay, so again, those 4 tiles, I can make a line going that way. I can make 3 going out and then 1 down below. All right, you sketch all the different ways. Okay, and then for each one, find the area of tiles and the perimeter of toothpicks. So the area of this is 1, 2, 3, 4. The perimeter is, get another colored pen. You can see the perimeter. Remember, those are toothpicks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the perimeter equals 10, and the area equals 4 on this. How about on this one? Sketch as many ways as you can. I'm going to leave myself a lot of room there because there's a lot of different ways on that. And you want to get the perimeter and area for each one. Go all the way down here, 1-87. And here you want to write 4 different fractions that are equal to 1. Okay, how do you do that? How do I make a fraction equal 1? Remember when you have the same numerator as denominator. So 2 halves equals 1. How about 5/5? Right? You're going to come up with some more. Get creative. Have fun with that one. There are infinite possible answers on that one. 1-88. I want to copy this table. Okay? And what they're saying is the multiples of 2 and the multiples of 3. Okay? Multiples, that's just something multiplied by, right? So the multiples of 2, you got 2, and you're just counting by 2's. Okay? And they go 6. So it looks like the first 9 multiples of 2, 4, 6, 8, 10, 12, 14, 16, 18, right? And then 3, 6, 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Yeah, those of you that have me for math intervention know that song. All right, 3 is a magic number. Google it if you've never heard it. It's a great song. Scholastic rock, multiplication rock. So the first part says, write down all the numbers that appear in both rows. Both rows. So you see there's a 6 in this row and a 6 in this row. That's going to be the first one to write down. Write down all of them and then describe a pattern that you see. Okay, I think you can do that. For B, what is the smallest number that appears in both rows? Well, I'll give you a hint. I already said it. Okay, that is called the least common multiple of 2 and 3. Okay, find 3 more common multiples of 2 and 3. You kind of did that in A, so that's an easy question. And D, can you find the largest number that's a common multiple of both 2 and 3? And if so, what is it? And if not, why not? Why can't you do it? Okay, I don't know if there is or not. I'm going to let you think about that. Okay, common multiples. On to 1-89. And that question, let's go ahead and flip over here so since it's on the other page, we'll work on this side now. How many hands long is your bed? Okay, that's, you're going to get an estimate first and then go measure. See how many hands. Okay, how about my hands? Yeah, I got some big hands, huh? It's bigger than a book. Uh-oh. Yeah, is that a good way to measure things? Okay, so you're going to try those two at home. And 1-90, almost done here. 1-90, it says put a number on that box. And for A, we want that to be equal to 1. For B, we're going to put a number in that box, and it's going to be greater than 1. For C, we're going to put a number in that box, and it'll be less than 1. For D, number in that box, and that equals 0. And for E, this is the challenge one, number in that box, and that answer is bigger than 100, greater than 100. Okay? Now, if you're watching this video and you're still with me after almost 10 minutes, then you get to write on your answer for this one. Mr. Daniels said I can skip this. Okay, you can skip the patterns. I don't know if you see the pattern though. You got those 4 dots there, and then the next one I'm going to have one more on top, one more on the bottom. So I'm adding 2. The next one I'm going to add one more on top. I'm adding another 2. Each time I'm going to add 2. Right? So yeah, you would figure out what would the fourth and fifth figure be, right? This is 1 on top, 1 on the bottom, and 1 on each side. This is 2 on top, 2 on the bottom, 2 on each side. Figure 3, 3 on top, 3 on the bottom, plus these 2, right? So 4 is going to have 4 plus 4 plus a 2. 5 will have 5 plus 5 plus 2. The 50th will be 50 on the top, 50 on the bottom, plus the 2, 102. Okay? So that's how you do that one. Let's go to 1-92, and we're doing the prime factorization of 24, and then of 52, and then of 105. And again, in my class, we do the factor tree first, right? Factor tree first. Now, what do I mean by that? Let me do an example real quick. If it was like 36, you can do, this is 4 times 9, but some people do 36, and they say, well, that's 3 times 12. And some people do 36, and they say that's 6 times 6. Now, I'm going to show you how it doesn't matter how you start. I'm still going to go down, find a prime number. Once I get to a prime number, I circle it. Now, this is the same as 2 times 6. 2 is prime, I circle it. But the 6, I can do 3 times 2, right? Now, I take those numbers and put them in order and make a multiplication problem. So I got 2 2s and 2 3s, 2 times 2 times 3 times 3. And you can rewrite using exponents if you want. So 2 to the second power, 2 squared times 3 squared. Here, the 4 is the 2 times 2. And check this out. If I did it like that, they end up in order anyway. 2 times 2 times 3 times 3. And again, you can rewrite it using exponents. 6, 2 times 3, 2 times 3. Take those, put them in order. 2 times 2 times 3 times 3. And again, you're seeing no matter how I start, I end up, if I do it right, with the same answer. Okay? You're going to do that for 24, 52, and 105. Prime factorization. All right? All right, good luck, everybody. Use those ebook hints if this wasn't enough to get you over the hump and make this problem, this math assignment, really easy for you, okay? All right. Have a good one, everybody.